When transitioning from a polyvinyl chloride or PVC riser to a steel conduit, proper bonding is crucial to ensure electrical safety and code compliance. This involves creating a continuous electrical path from the grounding electrode system to the meter base. Several key aspects need attention, including relevant codes, thread specifications, bonding requirements, and installation procedures. The National Electrical Code, or NEC, and American National Standards Institute, or ANSI, CT.1 are relevant codes to consider. Thread specifications are important for ensuring proper connections. For the PVC riser, a common thread specification is 1/2" 14 National Pipe Thread, or NPT. For the steel conduit, a common thread specification is 3/4" 14 NPT. The bonding requirements dictate how to properly bond the steel conduit to the PVC riser. The short section of steel conduit must be bonded to the PVC riser to provide a continuous electrical path from the grounding electrode system to the meter base. The bonding damper must be copper or aluminum with a minimum cross-sectional area of 6 American wire gauge or AUG. It should be installed using a bonding clamp or another approved method. Here's a step-by-step guide on how to install the bonding jumper. Firstly, install the PVC riser 6 inches above ground. Secondly, connect the 4-foot section of steel conduit to the bottom of the meter base using a threaded coupling. Thirdly, thread the bonding jumper onto the 1/2" NPT fitting on the PVC riser. Fourthly, connect the other end of the bonding jumper to the 3/4" NPT fitting on the steel conduit using a bonding clamp or another approved method. Fifthly, ensure the bonding jumper is properly tightened to make a secure electrical connection. Referring to specific sections of the National Electrical Code, or NEC, can be helpful. NEC 250.104 covers the grounding of equipment. Additional resources such as articles on NEC 250.104 and videos on bonding metal electrical conduit to non-metallic electrical conduit can provide further clarification and guidance. In summary, bonding a PVC riser to a steel conduit requires attention to detail and adherence to established codes and practices to ensure a safe and reliable electrical system. The NPT, or National Pipe Thread, is the U.S. standard for screw threads used to join pipes and fittings. It is a tapered thread, which means that the diameter of the thread increases or decreases along its length. This taper creates a tight seal when the threads are tightened. NPT threads are commonly used in plumbing, HVAC, and other applications where a leak-proof seal is required. There are two main types of NPT threads. Firstly, National Pipe Thread Tapered, or NPT, which is the most common type of NPT thread, and secondly, National Pipe Thread Straight, or NPS, which is a straight thread that is used for mechanical joints. When selecting NPT fittings, it is important to choose the correct size and thread type for the application. It is also important to use a pipe sealant to ensure a leak-proof seal. A bonding jumper is a conductor that connects two or more metal parts together to create an electrically conductive path. This path helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electric shock. Bonding jumpers are commonly used in electrical systems to connect metal conduits, enclosures, and equipment grounding conductors. The size of the bonding jumper is determined by the size of the circuit conductors. The National Electrical Code, or NEC, provides specific requirements for the size and installation of bonding jumpers. Bonding clamps are used to connect bonding jumpers to metal parts. Bonding clamps are typically made of copper or aluminum and are designed to provide a secure electrical connection. It is important to select a bonding clamp that is compatible with the materials being joined. For example, a copper bonding clamp should be used to connect a copper bonding jumper to a copper pipe. The grounding electrode system is a system of conductors and electrodes that are used to connect the electrical system to the earth. This connection helps to protect people and equipment from electric shock. The grounding electrode system typically consists of a ground rod, a ground wire, and a bonding jumper. The ground rod is driven into the earth and the ground wire connects the ground rod to the electrical system. The bonding jumper connects the ground wire to metal parts of the electrical system. Proper installation of a grounding electrode system is essential for electrical safety. The meter base is the enclosure that houses the electric meter. The meter measures the amount of electricity that is used by a building or home. The meter base is typically located on the outside of the building, near the point where the electrical service enters the building. The meter base must be properly grounded to protect people and equipment from electric shock. Electrical safety is paramount when working with electrical systems. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and eye protection. Follow the National Electrical Code, or NEC, and other applicable codes and standards. If you are not qualified to work on electrical systems, hire a licensed electrician. Understanding and adhering to these principles will help ensure a safe and compliant electrical installation when transitioning from PVC riser to steel conduit. The American wire gauge, or AUG, is a standardized wire gauge system used predominantly in North America for the diameters of round, solid, non-ferrous, electrically conducting wire. The higher the gauge number, the smaller the wire. This system is commonly used for electrical wiring in buildings and appliances. The AWG table provides information on the diameter, cross-sectional area, and resistance of different wire gauges, which is essential for selecting the appropriate wire size for a given application to ensure safety and prevent overheating or voltage drop. When selecting wire for electrical applications, it is crucial to consider the ampacity, which is the current carrying capacity of the wire. The ampacity is determined by the wire gauge insulation type and installation conditions. The National Electrical Code, or NEC, provides tables that specify the ampacity of different wire sizes under various conditions. Using wire that is too small for the intended current can lead to overheating, insulation damage, and even fire. Therefore, it is essential to consult the NEC and use appropriate wire size and calculations to ensure electrical safety and compliance. The National Electrical Code, or NEC, is a widely adopted code in the United States for the safe installation of electrical wiring and equipment. It is updated every 3 years to incorporate new technologies and address emerging safety concerns. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring electrical safety and preventing electrical hazards. The NEC is developed by the National Fire Protection Association, or NFPA, and is based on consensus among experts in the electrical industry. It is adopted by state and local governments, and is used by electrical inspectors to ensure that electrical installations meet minimum safety standards. The NEC is a comprehensive document that provides detailed requirements for electrical installations. It is essential for electricians, electrical engineers, and other professionals in the electrical industry to be familiar with the NEC and to follow its requirements when designing and installing electrical systems. Overcurrent protection is a critical aspect of electrical safety. Overcurrent protective devices such as circuit breakers and fuses are designed to interrupt the flow of current in the event of an overload or short circuit. This prevents overheating of conductors and equipment and reduces the risk of electrical fires. Circuit breakers are resettable devices that can be manually or automatically reset after an overcurrent event. Fuses are one-time devices that must be replaced after an overcurrent event. The selection of the appropriate overcurrent protected device depends on the size of the circuit conductors and the type of equipment being protected. The National Electrical Code, or NEC, provides specific requirements for overcurrent protection, including the maximum allowable current rating of overcurrent protective devices. Grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip overcurrent protective devices and prevent electrical shock. Grounding also helps to stabilize voltage and reduce electrical noise. A grounding system typically consists of a grounding electrode, a grounding conductor, and bonding conductors. The grounding electrode is a metal rod, pipe, or plate that is buried in the earth. The grounding conductor connects the grounding electrode to the electrical system. Bonding conductors connect metal parts of the electrical system together to ensure that they are at the same electrical potential. The National Electrical Code, or NEC, provides specific requirements for grounding, including the size and installation of grounding conductors and bonding conductors. Equipment installation is a critical aspect of electrical safety. The electrical equipment must be installed in accordance with the manufacturer's instructions and the requirements of the National Electrical Code, or NEC. Proper installation ensures that equipment operates safely and reliably and reduces the risk of electrical hazards. Equipment must be properly supported, protected from physical damage, and adequately ventilated. Connections must be made securely and insulated properly. The National Electrical Code, or NEC, provides detailed requirements for equipment installation, including clearances, wiring methods, and grounding requirements. Electrical hazards can be prevented by following safe work practices. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and eye protection. Inspect electrical equipment regularly for damage. Do not overload circuits. If you are not qualified to work on electrical systems, hire a licensed electrician. Following these safe work practices can help to prevent electrical shocks, burns, and fires. Additionally, understanding the specific requirements for bonding PVC to steel conduit using the correct materials and techniques, and adhering to the NEC guidelines ensures a safe and compliant electrical installation. The role of the electrical inspector is very crucial in maintaining electrical safety. Electrical inspectors are responsible for inspecting electrical installations to ensure that they meet the requirements of the National Electrical Code, or NEC, and other applicable codes and standards. Inspectors typically review electrical plans, conduct on-site inspections, and issue permits and certificates of compliance. Their work helps to ensure that electrical installations are safe and reliable, and reduces the risk of electrical hazards. Inspectors are trained and certified to identify electrical code violations and to provide guidance on how to correct them. They play a critical role in protecting the public from electrical hazards. Electrical plans are very important in complex installations. Electrical plans are drawings that show the layout of electrical wiring and equipment in a building or structure. The plans typically include information on the location of outlets, switches, lighting fixtures, and other electrical devices. They also show the size and type of wiring, the location of overcurrent protective devices, and the grounding system. Electrical plans are used by electricians to install electrical systems and by electrical inspectors to verify that the installations meet the requirements of the National Electrical Code, or NEC, and other applicable codes and standards. Accurate and complete electrical plans are essential for ensuring that electrical installations are safe and reliable. The National Fire Protection Association, or NFPA, is a non-profit organization that develops and publishes codes and standards related to fire safety and electrical safety. The NFPA's most well-known publication is the National Electrical Code, or NEC, which is widely adopted in the United States for the safe installation of electrical wiring and equipment. The NFPA also develops codes and standards related to fire protection systems such as sprinklers and fire alarms. The NFPA's mission is to reduce the worldwide burden of fire and other hazards and the quality of life by providing and advocating consensus codes and standards, research, training, and education. The NFPA plays a critical role in promoting fire safety and electrical safety around the world. A short circuit is an abnormal condition in an electrical circuit where current flows through an unintended path with very low impedance. This can cause a large amount of current to flow, which can overheat conductors and equipment and potentially cause a fire. Short circuits can be caused by damage to insulation, loose connections, or accidental contact between conductors. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of a short circuit. It is important to identify and correct the cause of a short circuit to prevent recurrence and ensure electrical safety. An overload is a condition in an electrical circuit where the current exceeds the rated ampacity of the conductors or equipment. This can cause the conductors and equipment to overheat, which can damage insulation and potentially cause a fire. Overloads can be caused by connecting too many loads to a circuit or by using equipment that draws more current than the circuit is designed to handle. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload. It is important to avoid overloading circuits and to use appropriate overcurrent protection to prevent overheating and ensure electrical safety. The impedance is the measure of opposition to alternating current, or AC, flow in an electrical circuit. Impedance is similar to resistance in a direct current, or DC, circuit, but it also takes into account the effects of capacitance and inductance. Impedance is measured in ohms. A low impedance path is desirable for grounding to allow fault current to flow back to the source and trip over current protective devices. High impedance can limit fault current and prevent overcurrent protective devices from operating properly. Understanding impedance is important for designing and troubleshooting electrical circuits. Capacitance is the ability of a component or circuit to store electrical energy in an electric field. Capacitance is measured in farads. Capacitors are used in electrical circuits to store energy, filter signals, and provide power factor correction. Inductance is the property of an electrical circuit that opposes changes in current. Inductance is measured in henries. Inductors are used in electrical circuits to store energy, filter signals, and limit current. Together, capacitance and inductance contribute to the impedance of an alternating current, or AC, circuit. Power factor correction is a technique used to improve the efficiency of electrical systems. Power factor is the ratio of real power to apparent power in an alternating current, or AC, circuit. A low power factor indicates that the circuit is not using energy efficiently. Power factor correction involves adding capacitors to the circuit to reduce the amount of reactive power and improve the power factor. This can reduce energy consumption and improve the performance of electrical equipment.